Good evening, sir.
Good evening.
Yes,
So
yes.
we can start.
Yes, sir.
So today we are continuing our discussion on control wall. Last time we seen some positioners, smart positioner, purpose positioner. Now we see some further technical part. How you have to understand some important terminologies about the wall, because wall is very important as far as uh, process industry is concerned. And earlier also I told ki wall use a maximum maintenance budgets out of 100%, say for out of 100 rupees, uh, 60 rupees goes to the almost to the control wall maintenance. So how important it is. And 40 goes to the field input side, means transmitters and sensors. And hardly 10 rupees goes for the DCS or a control room instrumentation automation system maintenance. So, or this is the what a failure strategy also more in the control wall. Control wall fails more, frequency is more. Therefore, entire attention is on the control wall in the process industries. So you see the just I'm refreshing back. This is the one flow closed loop. This is the control wall controlling the flow inside this this ORPS transmitter, and this is the FIC loop, flow indicating control wall, I2P and control wall. So you see control wall accessories here, control wall main part here in the cut portion you can see here is the plug and seat. This shining portion you can see here now. This one is a plug and it is resting on the seat, and flow is controlled between plug and seat opening area. However, the stem, diaphragm, spring, and this is the positioner part, right? And in industrial setup, this you see the wall is installed in the one of the industrial process line, that is a steam line, steam pressure line, high pressure steam with a high temperature also. Therefore, you can see the way it is insulated. And this is the wall with the smart positioners, hard positioner we can say on this body. So the way it is, you see the nut bolt mountings, how it difficult for maintenance. Then you can understand the time required, energy required, money spent, and overall that you require different manpowers. Means to open these, then to bring it to the workshop to calibrate such heavy equipment. A lot of uh, uh, machineries are required, means to carry it to the control wall to the workshop side also. Small cranes, then jumbo like machines are there, like a small truck type we call in the industry jumbo, with a three wheel, and it carries the entire control wall to the control this instrument workshop for maintenance. And then back after calibration or testing or repair, it is taken back to the site, and then again it is installed tight. You have to check the entire thing, leakages, then again this covering you have to do, which has you can see the wire mesh, glass wool, entire thing you have to take care. And in this control wall you can see these isolation walls are there. You can see the isolations walls here, here isolations walls. When you have to stop the line or bypass the line from here to here, like this, the isolation walls are also there. So in this wall you can see this is the globe body. Inside this plug and seat is there, stem is there, again this link is there, this is a diaphragm. So this is a major accessory you can visualize here. You can see here the wall little clear for your understanding. The direction of the wall flow also mentioned here. You see here the way you have to follow. See, this is the input side and this is the output side. This way you have to follow these directions, right? and the backside link is there. You see your stem is there, and this is the linkage part, mechanical link, which is attached to the positioner, and then the signal, actual position signal, goes to the positioner here through this link. So in the dictionary, you can see wall control consists of mechanical device for controlling the flow of liquid. So this is the definition of wall. Wall is a device which controls the amount and direction of fluid flow by opening, closing, partially obstructing, or providing one or more passageways to the fluid in a pipeline system. This is the, as per standard, this is the definition of the wall. So when we say control wall or wall is a device. Mm. Every piping system must have walls in control the amount of and direction of fluid flow through the system. So wall, there are variety of the walls like a stop wall, check walls. So we will not go in detail because our topic related because in the instrumentation we remaining walls are in the mechanical department. We only uh, maintain, operate, calibrate, test is a control wall. So as per the group's walls, you can see the fluid walls, stop wall, check walls, and special walls. So you can see here various types of stop walls, gate walls, globe wall, plug wall, ball wall, butterfly wall, slide wall, check walls, swing check, lip checking, and then special walls, but safety walls, pressure relief wall, pressure reducing walls. These walls we in instrumentation we maintain safety walls, and in this category we use in the globe body control wall this body shape is a globe, and on top of that control is not manually, control is through automatic, so we through positioner. So this is the way here control wall comes. So I'm skipping some slides which are not now not required. So hand operated walls and automatic control system walls used in automatic control system are called control walls. That is our area. So walls used in automatic control automation systems are called control wall. And as I told, the basic construction of wall, the disc or open or close the water flow, the wall body to seat that I have shown. So I will show you on another slide detail. Classification as per wall operating device. Manual wall, so wheel is there. That is in certain cases it is by default it is required. In case your automatic control fails, manually you have to operate. Automatic control system, mechanical operated, motor operated, pneumatically operated, hydraulically operated, and solenoid operated. So there are variety of the options available based on your application in the control walls in the automatic control systems. You can use motorized, you can use pneumatically, you can use solenoid. In certain cases you can have a hydraulic operated also. Manual means wheel. A hand wheel or a lever is directly connected to the stem and it is operated by hand. So that is a manual control. Hydraulic means hydraulic pressure is applied to one side of the piston which is connected to the stem of the valve. So either hydraulic means oil mostly used. Motor operated for a high pressure. Hydraulic, electric or air driven motor is used to turn the stem of the valve. This we use solenoid uses an electromagnet to open or close the valve against the spring pressure. This is the total mechanical, the rods and gears. This is the PID symbols. Main process line, thick line. Other process lines, slightly you see here other process lines and utility lines. Water spray gate wall symbol is this, globe wall symbol is this, check wall symbol is this, plug wall. Only you can see here uh, on the globe body, just put a line and just diaphragm is your control wall symbol. I will show you in some other slide. Hmm. So this is your control wall symbol. You see here, this is a motorized operated electrical motor. Safety wall is shown like this. Hmm. Now wall sizing and selection. So I'm coming to this point, important point. So the usual rule of thumb is that wall should be designed to use 10 to 15% of the total pressure drop or 10 psi, which is a greater. See here, this is thumb rule. Should be designed to use 10 to 15% of the total pressure drop. Means if you have in the line size pressure drop between this range, the wall, you have to see that okay, total pressure drop, whatever it is, should be designed to use 10 to 15% of total pressure drop. Means if you have a design for, say for example, 100, out of that only you use 10 to 15%, whichever is a greater, or 10 psi. So that much margin you have to keep for safety. Why? Key variable for wall selection: total pressure drop at 100% open. Means if the wall fully open, design flow, operating flow, minimum flow, pipe diameter, specific gravity of fluid. Remember that the system pressure drop is limited by the pump. Maximum pressure drop available for wall as per this standard. You can see larger pressure drops increases the pumping cost. That is what it is used for this. And smaller pressure drop increases the wall cost because of a larger wall is required. So wall sizing equation: correction factor, wall coefficient CV, wall coefficient allows the selection of proper size of wall to accommodate flow rate. So CV is a very important parameter here that allows the proper size of wall to accommodate the flow rate. Means whatever your flow rate, for that if you have properly calculated CV, and based on CV if you have purchased the wall, then it will control properly. So you can see here, measured as a, what is CV? Measured as a number of US gallons of water. See here, measured CV measured as a number of US gallons of water per minute flow through the full open wall with a pressure drop of 1 pound per square inch. Means you see here, you, when wall is fully open, at that time see here, measured as a number of US gallons of water per minute. So you are measuring the water flow inside the wall when wall is full open and a pressure differential is 1 pound. So that is the CV calculation formula. Q is the flow rate, means how much water goes. That is equal to CV under root of delta P into Hg. So delta P is a pressure across the wall. So this is the 1P here. And liquid specificity is a constant. So here entire thing is a constants. So selecting the right wall. Our discussion will focus on capacity, pressure recovery, and wall geometry. So we'll see one by one. So these three important parameters are for selecting the right wall. So other general things like material of compatibility must be considered. Means construction material, because of your uh, flow flowing material, type of material like acids, slurries, or gas, temperature, corrosiveness, property of that particular liquid. So all these are related to your, you have to accordingly you have to uh, select the construction type material, like a type of a steel for construction. So selection based on marketing and economics. In today's dynamic business environment, major manufacturers are under extreme economic pressure. So market globalization is resulting in intense pressure to reduce manufacturing cost to compete with the lower wages and raw material cost of emerging countries. This is what the general trend when the economy goes down. So competition exists between international companies to provide the highest quality products and to maximize the plant throughputs with the fewer resources. Although the meeting ever changing customer needs, see, all these are the challenges. To meet the customer needs, you have to see that cost and quality. These marketing challenges must be met through fully complying with the public and regulatory policies. Again, you cannot ignore the your regulatory compliance. So you cannot suppose wall required for acid services is costing with 20 lakhs with whatever specified construction material and quality. The same wall, if you suppose purchasing with the 10 lakhs with compromising the quality of the material, definitely it will be hazardous if the leakage is there and the gas will hazardous gas will come out, and the environment will get pollution polluted, as well as it will be the casualties staying around people, societies. So wall selection process, so determine service conditions, input pressure, differential pressure, flow rate, temperature, means fluid properties, allowable noise, etc. Select appropriate ANSI pressure class required for wall body and trim. So as per ANSI, American standards, they have given a classification as per the wall body and trim requirement. What type of a pressure class? Then calculate a preliminary. So once you got a wall body and trim, then calculate a preliminary CV required. Nowadays, a lot of means very user friendly softwares are available. Check noise and cavitation levels. So select a trim type. If no noise or cavitation indication, choose standard trim. If aerodynamic noise is high, choose a whisper trim. So while selecting the trim, you have to see that wall, whether noise, cavitation, or uh, any abnormal sound is coming. So accordingly, your trim is selected. Select wall body and trim size. Select the wall body and trim size with the required CV. See, those are external factors which you have to properly select based on your process requirement and wall previous experience in the wall. Note travel, trim group, and shut off. These are available nowadays, as I told, in the softwares also. Select the trim materials for your applications. So material of construction is very important. Make sure trim selected is available in the trim group of the wall size selected. So you will get a selected wall, and then accordingly in the software you will get the trim options, and consider the option for shut off, stem packing, etc. So wall body material, as I told, is very important, usually based on the pressure, temperature, corrosive properties, and erosive properties of the fluid media. So um, here you can see the case study. For instance, a material with a good erosion resistance may not be satisfactory because of poor corrosion resistance when handling a particular fluid. So based on your handling particular fluid properties, you have to select the wall uh, body material. That is what it is here. This is very important for some standards are there, class designation and PN numbers. So uh, for example, class 150, PN is 20. This way normally industry people talks for we require wall with a class 150 means what. So that is what it is mentioned. This is very important for the uh, early stage. So the PN is actually United States standards. There are two systems for design, designating and pressure temperature rating of the walls. एक आता है United States and some other parts of the world use the class designation. This is a class. The nominal pressure PN designation system is used in Europe and most other parts of the world. So PN is other countries, while American they use a class. Even German they use a DN also. So you can see here number six. However, for the PN designation, it is normally the cold working pressure in the bar. In the international standard organization ISO standard 7005 7005-1 1992 version, metallic flanges part 1 steel flanges. So like this they mention in the standards what type of a body material is required. The class designates have been converted to nominal pressure designation. These are equivalent. So equivalent PN for class 150 is a PN. So this way it is there. So the rate of flow through a wall under stated condition. How big does may wall need to be? We need to know inlet pressure. See, while specifying the wall your services, these parameter process parameters you have to uh, mention. एक तो आता है इनलेट प्रेशर P1, दूसरा है आउटलेट प्रेशर, then delta P means pressure drop across the wall. When wall is installed, the differential will like orifice plate upstream downstream. So same way DP also generated. Then flow rate, then fluid type and its properties. As I told, for it's required for construction material as well as type of a wall selection is plug and sit. Then fluid temperature. So how big does my wall need to be? And based on that, CV is a flow coefficient, a constant CV related to the geometry of a wall for a given travel that can be used to establish a flow capacity. So CV is nothing but it gives the flow capacity. It is the number of US gallon per minute at ambient temperature at 60 degree Fahrenheit water that will flow through wall with 1 pound per square inch pressure drops. Normally this definition is always there asked in either in interviews, aptitude test in the beginning. Later on we become through, but initially we get a confusion in what is CV and all. So for you advise is that go through the definition, try to understand how it is important to the wall design. So wall's capacity is measured in terms of CV. For liquids, for liquid flow, CV is Q into square root of specific gravity and delta pressure. Read Q is equal to CV, same, or even dP is equal to this. Then CV was invented by Masonil. So Masonilian is one of the reputed manufacturer in the critical wall manufacturing. Mussolini, Fisher. So, but the CV term invented by them, Masonilin. So, control wall sizing, you see this uh, quarter inch wall, 0.3 CV, control flow coefficient for different size walls. So, accordingly, CV, you will get this chart for 3 CV, half inch wall, 14 CV, 1 inch wall. So, as your CV goes on, increases the size of the wall increases. So 725 is the CV, and for that wall size required is 8 inch like this. So wall's geometry determines how well it can take a pressure drop. So main is a pressure drop. So how does it to get from P1 to P2? P1 is your wall upstream side, and P2 is your downstream downstream side pressure. So FL is a rated liquid pressure recovery factor, is the measured of the wall's efficiency in getting from P1 to P2. So 1.0 is a perfect. The best wall will have 0.994. Butterfly and ball walls have zero point 0.6. So ideal is 1. Means the more torch tortuous the path, the higher the FL. Means a scrubbing part. I'm talking. The wall geometry means a type of a shape of the wall style is the which wall style is best. Gate wall, butterfly, ball wall, rotary, reciprocating, top guided, cage guided, it's like this. So one of the wall you can see the construction here, gate wall, cutway gate wall. This top wall you can see the wall body. Major part you can see is a gate disc. This is a disc when it is flow is controlled. Body, bonnet, stem. This is the wheel through hand wheel basically, and you can just spring, yoke, bonnet, bushing for this bushing is there leakage to avoid leakages. It's a mechanical construction. Mm. And you can see the globe wall with a linear motion. These are all mechanical as I told, but shape is a globe, and you can see here inside and outside, and in between you can see plug seat gap is there, and through the path is generated. Outside path is generated. So globe wall parts again, flow in, flow out, screwed ends, this side nut bolts, plug type disc here, packing nut, hand wheel. Mm. So globe walls are linear motion walls, and with a rounded bodies from which their name is derived, round eye. It is acceptable in a wide variety of industrial application from light industrial, petrochemical and power. Maximum it is a globe body in the industries. Used for regulating fluid flow in both on-off and throttling services, high pressure drops, high temperature applications, use where some fluid trapped in line is ob, is not objectionable. So globe wall is very very important as far as the industry is concerned. Most of the refineries you see these walls, maximum walls. So you can see the external blue portion is wall body. Wall seat is this one, and this is the plug sitting on this disc washer here. Disc is here, washer is here. This is a seat. Union bonnet rings. This is a bonnet. Lock washers. These are the packing material. Disc stem ring here. Bonnet. This part, external part is a bonnet, and packing nuts, glands again. Packing here. Here's a gland packing is there to avoid leakage to come out this gas. Stem, wheel nut, and this is a wheel. So globally, regulation as well as on-off duty, throttling duties, these are application frequent operation. Then butterfly valve. That actually it's a disc. Normally for slurries it is used. Slurries. Slurries means mud and all. So hand operated valves. So to avoid a choking, so this type of disc is there. Mm. So butterfly wall has a thin rotating disc. This one, it varies within a quarter turn from fully open to fully closed. So there is no control, either fully open or fully closed. Maybe used for throttling purposes in addition to on-off control. Use in a large pipes. In the large pipes, you will see butterfly walls. So this is a butterfly wall. So butterfly type disc. This will seat inside portion, body outside portion, position plate, and this hand. So hand, using hand, you can have either open or close the wall. See, now it is open. Just you turn, it will look. Disc will get a close on the. This will sit on. This will, this butterfly disc will come and cover the seat and close the wall. Quick acting, has a body resilient seat, butterfly disc, stem packaging. Can this is used for fresh water, salt water, lube oil, and chill water systems. Mm. So I'm skipping this design and all. Not this also not require butterfly wall. The other types of butterfly wall, large diameter lines. Mm. So then now you can see hand wall, two piece, three piece. This one, just check it. This is the superior low torque, low profile design result in economical operation. These types of walls you see in the line. Two piece ball wall. This is called ball wall. Isolation purpose it is used. Ball walls. So I'm see the picture of industry refineries. These are the storage tanks that is called spears, Horton spear covered, where you can store your chemicals, gases, even ammonia is an our store here. These are also vessels here. So adjusting walls. Do you believe in automation? Do we run around the plant to adjust the walls when required? So there are control automatic means yes, we can automatically control the wall operation. Yes. Mm. So you need not to go up to check the operate the walls. From control room you can operate it. So earlier picture was showing the you have to you go at the location field which is very critical to reach. Now it is not required. From the DCS control room, from sitting here comfortably, you can operate your critical locations. Here locations are shown critical locations. Means it is very difficult to the human being to reach to that locations. But earlier we have to manage it, but now the technology helps. From control room you can operate the wall, control the wall. So from the DCS control room you can see overview the entire process and make a immediate adjustment anywhere. Safe location history of a past operation is also there available. So wall history is also available nowadays. So control wall with actuator and body. Again we are coming to our topic. So you see here some numbers are given uh, for the parts, but what is the main is actuator and body part here. The actuator provides the ability to change the flow resistance, that is the size of opening of the wall, this portion. And the most common actuator is a pneumatic diaphragm. You see these are the pneumatic diaphragm here. The body of the wall defines the flow path and is selected to achieve the desired flow. This is the body of the part. So main parts I can just here the flow goes: seat, plug, stem, yoke, globe body, spring, diaphragm, and this is the enclosure. That's all. And here you have a link to the control wall, and the scale is there. How much percentage wall is open, that you can physically also see when you are taking around to the control side. It is difficult to see now, but as the parts I have mentioned, same is here. Mm. So color as a, but here you can see this is the plug, seat, stem, yoke. This is diaphragm. This is the enclosure for diaphragm cover, and this is the globe body. What are the important features for process control? Wall features, capacity, range, failure position, gain, pressure drop, precision, linearity, consistency with the process environments, and dynamics and cost. These are some wall features, very important to note. So wall features, capacity. Capacity is, as I told, it is related to CV. The maximum flow rate through the flow system, pipes, walls, process equipment must be meet operating requirements. Range means the range indicates the minimum and maximum, and what is your average. The indicates the excellent extent of flow values that wall can reliably regulate. Very small and large flow cannot be maintained at desired values. So range is reported as a ratio of largest to smallest. So rangeability can also be expressed as the ratio of the maximum to minimum controllable flow rates. So this is a range of the wall operation. Then pressure drop across the wall. So DP. So purpose of the wall is to create a variable pressure drop in the flow system. However, the large pressure drop wastes the energy. So I have shown you actuator, gain, this parameter. Actuator, this is a pneumatic, hydraulic, the type of actuators you use. Gain is the ratio output to the input change. Gain has a two components, static gain and dynamic gain. Static gain is the gain relation. So I'm skipping this terminology. So I think this picture is clear to understand the wall parts. So I'm coming from the top diaphragm. This is the diaphragm casing. This is outside is a casing and inside is a diaphragm. Diaphragm and stem shown in the down position. So you see here, this is the stem. Diaphragm plates, supporting plates. Loading pressure connections. From here, you can adjust the spring tension. Actuator spring. This is the spring when come as in control valve when you have to control the pressure. So that control is maximum depend on the diaphragm and spring. Spring seat where the spring is fixed here at this end. Spring adjuster, stem connector here, stem yoke. Yoke is outside part. This shape is called a yoke. This travel indicator, as I have shown, this is the indicator where how much wall is open that you can see externally. Indicator scale here. So these are the parts measure in the wall. So type of wall, direct or reverse actuator also available. Air to open and air to close. You see here air to open wall, and this is the air to close. So that depend on your air connections from where you are giving the air to the wall. Trim is an internal component of the wall that modulates the flow of the control fluid. The globe wall body trim could be typically include a closure member, seat ring, cage and stem pin. So inside part of this seat and plug. I will show you again this picture. So wall body different butterfly shape, globe shape, gate wall and ball wall looks like. Would a globe wall be good choice for slurry? Slurry as you are required. Answer no. The globe wall has a many small dead ends where particle could collect and could not removed by cleaning fluids. This globe wall is only for clean fluid, and butterfly was slurry. Would butterfly wall be a good choice when a tight closing is required? No, manufacturing would almost never provide a perfect fit. Would a ball wall be a good choice for a low, non-recoverable pressure drop? I'm talking about a ball wall, means this ball. No, the flows a tortuous path and experiences extreme turbulence. So you require would ball wall will not be for that process. Hmm. So control wall principles: flow rate in a process control, volume per unit time. If a given fluid is delivered through a pipe, the volume flow rate. This is on your Bernoulli's equation, right? Hmm. So control wall principle to regulate the flow rate of a fluid through pipes. So this is your flow, and this is a wall stem, wall plug, and the fluid is passing through this and going out. So this is the wall body and this is a seat. So placing a variable size restriction in a flow path, stem and plug move up and down. So this is the stem and this is the plug moving up and down based on your controller signal. Opening size between plug and seat changes thus the flow rate. So based on this gap between this and this, flow rate is changed. So typical flow system you can see here. Uh, you see here one of the process equipment here. Say for example your distillation column. Here it is cooled. This is a heat exchanger, cooling water here. So it is a high temperature. So it is cool down here, and you are getting some water heated or steam out of this. So it is called a waste heat boiler or like that. Or heat exchanger we can see here, and this is another your drum, and then it is pumped back. So normally we have seen in our distillation column loop. So this is the pump and this is the wall. So the wall application you can see here, flow transmitter, and this is a wall. Mm. So I'm this is the variability, process variability. I'm skipping this and not required. So performance test loop, that is at the manufacturer side they are done. Hmm. This all is manufacturers, control all manufacturers do this testing, wall type and characterizations. The style of wall used and the sizing of the wall can have a large impact on the performance of the control assembly in the system. While wall must be of sufficient size, that is very important. Hmm. Now we will come to the characteristics. Control wall characteristics: linear, equal percentage, and quick opening. So there are three characteristics you can see here. Equal percentage, equal increment in equal increments of wall travel produces an equal percentage of flow change. Linear flow is directly proportional to the wall stroke, and quick opening large increase in flow with a small change in wall stroke. So this is what the characteristics. So based on your process requirement, you have to select. Most of the industrial walls are linear categories. Linear, this one. So you can see the flow characteristics here. Wall lift in percentage, flow coefficient. So you can see this is a linear with the small wall lift, maximum flow you are getting here. So quick opening, and this you can see the equal percentage. So this is a flow characteristic curve. So application of linear and quick opening. Linear valves used in a liquid level or flow loops. Used in a system where the pressure drop across the wall is expected to remain fairly constant, steady state system. So it is a linear. Quick opening used for frequent on-off service, used for process where instantly large flow is needed. Safety systems, cooling water systems, even small stem motion, large flow rate like this. So quick opening. Then equal percentage walls, mostly common is wall control, used in a process where large change in pressure drop are expected. Used in a processes where a small percentage of the total pressure drop is permitted by the wall. Used in temperature and pressure control loops, equal percentage. The specifying the and sizing control walls. This we have seen again. Just this is the formulas. I'm skipping. Now we have some few terminologies, inherent wall characteristics that we'll see. Inherent function of the wall flow passage geometry and does not change the long as long as the pressure drop is held constant. So many wall design, particularly rotary walls, butterfly wall, eccentric plug walls have an inherent characteristic which cannot be easily changed. So, however, most global walls have a selection of wall cages or plugs that can be interchanged to modify the inherent flow characteristics. So, you can see here, mm, I will skip this. Uh, so, I'm coming to the actuation design based on action air to open wall and air to close wall. Based on construction, globe wall, angle shape, cage guided three-way butterfly wall. Control walls, air to open versus air to close control walls. Normally, the choice of air to open or air to close wall is based on safety considerations, based on your process safety interlocks. Engineer choose the way the wall should operate, full flow or no flow. In case of transmitter fail, in that line, if the measurement transmitters fail, so what should be the condition of that line? Whether it should be full flow or no flow. Hence, air to close or air to open walls often are referred as a fail open or fail close, fail safe wall. Fail open, when wall fails, line should be open. And when fail close means when wall fails, the it has to be close position. Fail safe, close position, fail safe, open condition like this. Now pneumatic control wall air to open. You see the air to open. So you see here actually flow direction, wall plug, wall seat is here, and this is a downstream side flow. Wall body is shown, wall stem is shown, wall indicator shown as a indicator. This is a diaphragm and this is the actuator. So you have actuator spring here inside this, and you see here this is the air to open means you are giving the air here actuating signal. Actuating signal means air signal goes below the diaphragm. In the air to moment air is there, it diaphragm is pushed against the spring and wall gets open this way. You see, due to the air signal, say for example 12 psi air has come, so it will push this diaphragm upward side. Accordingly, the stem, this stem will come, will the gap between seat and plug will be more, so wall will be open. And air to open walls. Choose an air to open wall for application for which it is desired to have the wall fail close. Choose an air to close for application for which it desired to have the wall fail open. So I just want to here show you this is air to open. Same way this actuating signal for air to close from above and the spring will be down. That is the only change. So in that case, valve will be air to close. Means what I told, this will be this side and the spring will be down. So moment the air signal come, uh, valve diaphragm pushes the stem down. So valve get close. Hmm. So material of constructions, normally you can see the control wall space, wall body, either cast iron, carbon steel, PVC, Hastelloy, Monel or bronze. Based on your, as I told, process liquid or gases, process uh, properties, process liquid properties. Wall trim means inside part. Inside part is very, very important. Therefore, SS316, HVD1, Hastelloy, nickel and Monel. These are costly material, but it is required for the wall because they are directly coming in contact with the process liquids. And then gland packing, Teflon, asbestos, graphite asbestos, or pure graphites. So these are the material of construction in the walls. If your temperature in the process line is less than 230 degree, then packing material has to be PTFE. Temperature is more than higher temperature, you have to use a graphite packing material, sealing material we can say in the wall between the nut when we are yoke, stem, plug, wherever you have a nut bolt type of fitting there, this material, this graphite or PTFE based on temperature condition you have to use. Several packing methods can be used depending on the service condition expected and whether the application requires compliance to environmental regulations. So if it is coming under regulatory compliance, then you have to, whatever suggested, same material you have to use. So you can see this is the what indicator scale is here, spring seat is here, adjuster, lower diaphragm. This I have shown, and this is the where packing material comes here. Here. Somewhere. So this is what we have so far covered the wall parts, their important, some definitions about the control wall, how it is size. That is what we have covered. So now I am giving you two, three special characteristics like a flashing, cavitation. What is the flashing? What is the uh, cavitation effect in the wall? Even though we design as per process requirement, but still flashing phenomena or cavitation happens. So what is that? To maintain steady flow of liquid through wall, the velocity must be greatest at the vena contracta where cross sectional area is least. So vena contracta tapping means differential pressure I'm talking where the increase in velocity is accompanied by a substantial decrease in pressure at the vena contracta. Means you see here, if the wall is there, it has a fixed vena tapping and all, differential is fixed. But when your fluid velocity increases, then what decreases the pressure at the vena contracta. If a pressure at the vena contracta should drop below the vapor pressure, you just see of that fluid, due to increase the fluid velocity at this point, bubbles will form in the flow stream. Means inside, if this happens, if a pressure at the vena, if the pressure at the vena contracta means I'm talking about the between the range of the control wall body, inside the wall, fluid velocity at this point, bubbles will form in the flow stream. Formation of bubbles will increase the, if the bubbles form greatly as the vena contracta pressure drops further below the vapor pressure of the liquid. If a pressure at the wall outlet remains below the vapor pressure of the liquid, the bubbles will remain in the downstream system and the process is said to have flash. So flashing can produce a serious erosion damage to the wall trim parts and the characterization by smooth and polished appearance of the eroded surface. Means when we maintain the wall, we say wall body and sheet has damage. That means because of flashing effect. And why flashing happens? Because of more velocity, fluid velocity. Another effect is a cavitation. On the other hand, if a downstream pressure recovery is sufficient to raise the outlet pressure above the vapor pressure of the liquid, the bubbles will collapse or import producing cavitation. So this is another effect. So collapsing of a vapor bubbles releases the energy and produces a noise similar to the what one could expect if gravel were flowing through the walls. Gur, 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 it's like that sound is common. If the bubbles collapse in a close proximity, the solid surface in the wall energy release will gradually tear away the material, leaving means it has a high energy when the bubbles explode, and that is the cavitation. And because of that, the internal wall, this internal part of the wall body get damaged. So wall selection for flashing services to avoid that flashing damage is characterized by smooth and polished appearance of the eroded surface. To review, the flashing occurs because of P2 is less than PV. So P2 is the pressure downstream of the wall and is a functioning of the downstream process and piping. PV is a function of the fluid and operating temperature. Therefore, the variables that define flashing are not directly controlled by the wall. So this effect because of process condition it has happened. Since the flashing cannot be prevented by the wall, the best solution is to select the wall with a proper geometry and material to avoid the minimize the damage. So that is what it is mentioned. So I think these are what cavitation definitions. Cavitation damage is created by a rough cinder-like appearance of the eroded surface. It is distinctly different from the smooth, so it will observe when you take the wall or open the wall. You will see these pictures. I will show you some pictures if available. Then noise is another. Hello.
Hello.
हाँ madam हाँ ठीक है I
Shall
am
we
closing
continue tomorrow, sir?
yeah definitely हाँ okay
Okay.
thank you madam thank you hello we'll close today thank you